Hi guys, so today I would like to talk about what is a variable. Oh, I should start with the first slide. So what is a variable? It's a simple question and the answer is not a complex one too. So don't worry. So this is actually the syntax to to initialize a variable. And in this case the variable is an integer, so int x equals to 2. So if you have no background in computer science, this might be a bit new. It's not complex and won't be that hard to understand, but let me explain a bit what's actually happening behind the scenes. So let's say this is the memory, right? This is the memory of a computer, and let's say this is the main memory or RAM. So let's say the memory is divided into lines. So there are a lot of lines, and in each lines there's one data. So let's say here you can store your name, which is Josh, and here I can store your age, which is maybe 99. Okay. So these are the data that so these are the data that you can store in this line. So you can store a sentence, a word, or integer, or a double, or a number with with decimal points, like maybe 1.2, anything like that. So how these things works is it's like you're telling the computer, by the way. So these are the data, right? So Josh 99 1.2. So after you store the data in the main memory, or the just the memory of the computer, how will you retrieve the data back? So how will you tell the computer, okay, I want this data? So how to tell which data that you want actually? So there's a unique address that is given to each line. So there's an address actually, and unfortunately the address is not a simple number like 1 2 3, something like that. The address will be in several bits, maybe 6 bits, 8 bits, anything like that. So and it's usually in hexadecimal. So um let's say in reality the address will looks a bit complex, like x1 to f2 6, something like that. 0x, I think so. Okay, it's okay. But I'm just telling that the address is quite complex, or not complex, but it's very long. So to uniquely address this line, there's actually an address given. So let's say I want um, the data that is stored in this line, which is Josh. So I will tell the computer, oh, hey, uh, I'm talking to the RAM. So hey RAM, can you give me the data that is stored in 12ff26? And the RAM will be like, yeah, sure. So it will go to this address and be like, okay, the data stored in this address is Josh. Okay, so I will give you the data, which is Josh. So this is how it will usually works. So when I tell int x is equals to 2, what I'm actually telling is, can you allocate a space? Can you allocate a space in this RAM? And then the space, in that space, I will store an integer, and that integer x2, is 2, and the x is the label I give to this line. So instead of addressing the line with this complex address, I will tell X. So you will store by the way, you didn't tell a specific address, right? So it's kind of like your processor's uh, choice which address for it to choose. It will usually choose the address that is free or it's not used by other programs. So let's say it will take here and it will store the 2 here, and the label is given as X. Actually there's actually a address here in this X. So probably the address be like 12F2 9 or something. So there's a complex address as actually given for this line, but since I didn't give like int 12F29 is equals to 2, so I didn't give the address. So instead of the address I gave it X. So when you tell when you in the continuation of the program, if I tell can you give me the value of X, what I'm actually telling is can you give me the address that is saved in this address. So that's how this usually works. That's why in high level programming you don't really need to care about the space. Sorry, the memory address. You can just give a random name or a random label for that address. So there's two ways actually to kind of like a declare variables. So first is just telling int x is equals to 2. So what you're actually telling is allocate a space in the memory and store an integer, and the integer is 2. So this is the memory and there's a lot of lines, and store in a random memory, a random line the value of 2, and the label given to this line is X. So if I call the X again, it will the RAM will go to X and take the value. Another way is, instead of just giving the values straight away, just you first declare the variable and then you give a value to this memory location. So in this first line, it will just go to this memory, the RAM, and it will allocate a space for you. Let's say it will allocate this space and it will give a label X, and there's no value here. This uh, it's empty. So in the second line, it will go to the same X memory address where the label given is X, and then it will store the value of 2 there. So this is how these two different things works. You might think like, okay, do I have to write the int here again? Well, no, because um, the Java will understand is if you write int or the date the type of the variable with the label, it will think that you're allocating a space again. So it doesn't work here because you already allocate the space and you already given the label X. So now you are telling that give me another space or allocate another space but with the same label X. Well, you can't do that because if you're asking again, maybe in the continuation of the program you ask the value of X, and that's if you do this thing, that's 2x. So which value the Java have to give? So there's an error there. So that's why you don't have to write the int again, because in Java the int with the label it thinks that you need to allocate the space again. So this is declaring the variable. This is kind of like initializing the giving the variable value. In this case, it's called initializing a variable where you give the label and the value itself. So that's all about variable. Hopefully it's you can understand more what's happening behind the declaring variables. And the next video I will talk about all the types of variables. Thank you.